Hey, welcome to YOLO Learning Channel, guys. So this is the last part of your transformations pretty much, and we call it inverse functions. So inverse functions is something that we seem like we don't do it all the time in math, but we actually do it all the time even in our life. So let's actually take a look at this very briefly. For the tutorial session, we have two chickens become two fried chicken nuggets, and then it comes back to the chickens. Well, that sounds really awkward and weird, but hopefully this helps you understand this. In order for us to make chicken nugget, chickens become chicken nugget. Like, we need to put the chickens into it, and in order for us to do so, this chickens become our input and this chicken nugget becomes our output, the result. So this is the usual function. We do something to have the output from the input. Like, there's a process that's going from input to output. That's the function. The process itself is the function. Then the inverse function is we basically just inverse the whole process of it. So somehow we put the output, the chicken nugget, and then goes through the inverse function, and we have our input back as the result. Okay, so hopefully this makes sense to you. And the very simple summary of this is then our input goes in and it comes as the output later on through the function. But for the inverse wise, it works a slightly different way. So for the inverse wise, when we put the original output and we get the input, it seems like we don't do this type of process in our life. However, but think of this way. Let's say you're making a pepperoni pizza. If you know what the ingredients are, let's say the doughs, sauce, cheese, pepperoni, you put them together in a nice way, put into the oven, and after the time, then you will get a nicely baked pizza out of the oven. But if you are trying to, let's say, create another type of pizza, and you usually have the pizza first from another store, and you try to study what the ingredients are, and by doing so, the inverse of, let's say, baking, you actually get to know what the ingredients are. So the ingredients were the input before, now it is the output through this inverse process of baking. That's what it is pretty much. Then the second thing is the domain and the range. Now, as I said before, the input and output, they switch their role. So the input usually, which is the x, and then after the function, we get the output, which is the y in this case most of the time. But they switch the order. Remember, they switch the order. So the output becomes your input, and then your input becomes your output. So then input becomes the result, and by doing so, your role switches, and doing so, your domain and the range also switches too. Okay, so your domain and the range also switches. Now then, for the graph wise, remember our output, the y, switches with the x, which is the input. These two rotates and these two values switches that way. So in order for us to do so, we cannot just switch the location of x and y by displacing them. All we have to do is we actually have to rotate the whole Cartesian plane, the xy plane. In order for us to do so precisely, there's a specific line that we have to rotate the whole Cartesian plane along with. So then that is basically something that is making 45 degrees to both x and y axes so that they are equally rotating, and that is our y equals x line. So this is another characteristic that you have to remember of. Your graph of the inverse function will be the mirror image of the original on the mirror, something called y equals x. So let's take a look at this stage 1 and stage 2 all together. They are actually quite simple and easy to do. So it says, find the coordinates of the inverse function of given points 1, 2, 3, -5, -2, 0, -6, -9, 4, 4. As I said, the x and y, the input and output, they switch their roles. So they switch their position as well. So the inverse then, very simple for the point. It will be 2, 1 as the first point switches, and then negative 5 comma 3, 0 comma negative 2, negative 9 comma negative 6, and finally we have 4 comma 4. Why doesn't the last one change? Well, 4 comma 4 you switch, it's still the 4 comma 4, right? Then the stage 2 is just the sketching. So the first example, same thing. The first thing that you have to remember of is the point switch, the x and y position. Get the points of the original function.
In this case is 0, 0, 1, 1, 4, 2, 9, 3, and then 16, 4.
So through the inverse, what you get is then the reverse of the x and y. So 0, 0 still the same, 1, 1 still the same, but 4, 2 becomes 2, 4, 3, 9, 4, 16. They switch. Plot all the dots, and that's all that is. So we have
0, 0, 1, 1, 2, 4. Well, 3, 9 is out of the grid, so I'm not going to plot it. I'll just draw a nice curve. And that's all that is.
And hopefully you notice it, that it kind of rotates it. We have this. Same thing. We have points
right here, here, and here. Remember, those are the points where either it starts and ends, or they turn the direction of. So the original is negative 4, 1, negative 2, 5, 1, negative 2, 4, negative 2, 6, 3. So the originals are very simple, and the inverses are also very simple. 1, negative 4 by switching x and y, 5, negative 2, negative 2, 1, negative 2, 4, and 3, 6.
Now, something that you have to be very careful of in this case, or in any type of inverse functions case, is where some people change the signs. Signs do not change, only the position of x and y changes. So please be careful. No number changes, no sign changes, just the position. Once you graph this, and then you will see something very, I will say kind of cool to me, but not to some. So let's take a look. I have the first point being 1, negative 4. So it will be down here.
I'll have first point being 1, negative 4, so down here. And the next point is negative 2, 5 being 5, negative 2, and then one after that, and another one after that, and then last one is 3, 6, so it is somewhere. Now once I draw the nice graph from the first to the second point, second to the third point, third to the fourth, and fourth to the fifth, and hopefully you notice I'll make the line slightly thicker for us to see something good.
Then hopefully you see that this one is a mirror image of each other along the y equals x line, right? If you actually fold it along, they actually are the same shape.
A few moments later.
Now the hidden stage, so instead of having a graph, you have an equation that asks to find the domain and the range. In order for you to do so, please go back to transformations, level 3, stage 1, 2, and 3. Without those, you will have a hard time understanding this, so make sure you go and watch those 3 videos. Then for this, we have f at x equals 3x squared plus 4. The original domain and the range, I'm going to make it very short. X is an element of real number. The range is then y is an element of real number, but y is greater than or equal to 4. As I said, their role switches, so your range now is y is an element of real number. See that this guy just turns into the output. Then the next one is this guy becomes the input, which is the domain. Then x is an element of real number. Remember, still x and y switches, so the y becomes the x becomes y, and then x is greater than or equal to 4. And that's all that is. Then the next one is a simple 2. The original one in this case is domain, where x is an element of real number, but x has to be greater than or equal to 4, and the range is y is an element of real number and y is greater than or equal to 2. So again, inverse functions, domain and range, they switch the role. So your new range was the domain, but just to switch the x to the y, and then y is greater than or equal to 4. The domain of the new one, or the inverse, is x real number, x is greater than or equal to 2. Now guys, this is not the proper way of setting the domain and range. Please remember how to do that and watch the level 3 of stage 1, 2, 3 in the transformations, and you will actually see a better idea. Now the last stage is very simple. Somehow the question is missing. The question is find the equation of the inverse. So find the equation of inverse function. Now, so the first thing is f at x equals 3x squared plus 4. And when you do these, the f inverse is f and the negative 1 in the exponent. This is not f to the power of, we don't read this way, f to the power of negative 1. That's wrong. Okay, so f and the negative 1 in the exponent, that means it is f inverse. So when you do these type of questions, remember the x and y switches their role. So all you have to do is, now f at x is, we can use it, but the simpler way that we can use is just switch that back to the y, and then 3x squared plus 4, then switch x and y, just to switch x and y. So then it will be x equals 3y squared plus 4. And you're trying to isolate the y. So when you isolate the y, we have x minus 4 equals 3y squared. Hopefully you remember how to do this using the backwards order of BEDMAS, or I call it SAMDAP. Then divide everything by 3, then y squared equals x minus 4 over 3. The last thing that we have to do is taking a square root of it. Remember, when you take a square root of something, the plus minus should be at the front, and this is something that you have to be very careful of. Okay, you have to be very careful of, otherwise you're going to lose marks for these. Now then, we're looking for the inverse, therefore the y now has to be switched to the inverse function. And that's all that is. Nothing really difficult, nothing really challenging. So let's then do the second example over here. Now we have f at x equals square root of the x minus 4 plus 2. So same thing, switch the f at x to the y, and then square root of x minus 4 plus 2, switch the x and y, and then x equals then y minus 4 plus 2. The rest then you just use is the SAMDAP to follow through.
Then we have x minus 2 equals square root of y minus 4.
And we square both sides to get rid of the square root. Then we get y minus 4 equals x minus 2 squared. Remember, you're squaring the whole side, so it's not going to be x squared minus 2 squared. Not individually squaring it, we are squaring the whole thing. Okay, we're squaring the whole thing. So then once you get this, we have y then equals x minus 2 squared plus 4. Now I will show it to you on the Desmos, and be really careful with this type of things. So here I graphed the 3 graphs on the Desmos just to show it to you. Now hopefully you can see it. Red one is our original function, and the blue one is the inverse function that we found through the algebraic process, and the green one is the mirror, the y equals x line, where the inverse function and the original function mirrors each other onto. Now if you take a look at it, the red one is only a half of the whole, let's say, parabola sideways, whereas the blue one is a whole parabola. And you have to take a look at it very carefully, which part of the blue one falls, or the mirror images, along the y equals x with the red one. If you take a look at the left half of the blue, will that actually look like the red graph if it is mirrored along the y equals x? Or is it going to be the right one that's going to be look like? So as you saw on the Desmos, our graph looked like this, and the other one was like this, and the green line, the mirror line, was going through that way. So think of this way, whether this half is mirrored or this half was mirrored, right? If you rotate it, which one do you think is the right one? And if you take a look at it very carefully, this is the right mirror image that it actually rotates along this way, right? So then there's gotta be a restriction to this, where x is greater than or equal to your vertex point. This was the vertex 2, 4. So anything that is to the right of the 2 actually is the mirror image of our original function. So then x is greater than or equal to 2. So be really careful with this when you're dealing with a radical function, especially the inverse function of the radical function. Tend to give you a whole parabola, but it is not the whole parabola. It's only the half of it, and you have to decide. Okay, so hopefully this was helpful. Not confusing much, and if you liked the video and if this was helpful, please don't forget to hit the subscribe and like button. Thank you for watching YOLO Learning. I'll see you guys next time. Bye bye.